In this lesson, I'll show you how to find the second derivative of a function. This is part 2 in the series. The question reads, find the second derivative of the equation y is equal to x plus 2 times the square root of x minus 3. Before I begin, I just want to show you how to represent the second derivative. You can write it as d squared y over dx squared, or y double prime, or f double prime at x, or if you're writing it in differential form, it will be d squared y. Let's go ahead and find the derivative. We'll start with the first derivative, and you'll need to use the product rule for this because we have a product which we'll call u, and this product is v. Essentially, we have u times v, and we can follow the product rule, which tells us that we'll keep this the way it is, x plus 2, and multiply it by the derivative of the square root of x minus 3. I'll show you that over here. X minus 3 square rooted is the same thing as x minus 3 to the power of half. To find the derivative here, we'll need to use the chain rule, where we take this 1 over 2, place it at the front, multiply it to the expression, and then subtract the exponent by 1, and then you find the derivative of x minus 3. The derivative of x minus 3 is simply 1. Simplifying this, we end up with x minus 3 to the power of negative 1 over 2 over 2. If you do not want to use negative fractions, you don't have to. In fact, you can rewrite this as 1 over 2 times the square root of x minus 3. I'll replace this now right next to x plus 1. And if I multiply x plus 1 by this, I should end up with 2 times the square root of x minus 3. I just found this part. The next thing that I'll do is add v times du over dx. Now I know what my v is. It's the square root of x minus 3, so plus the square root of x minus 3 times the derivative of u. That's easy. It's 1. I just found y prime. The next thing that I'll do is find y double prime. This is where it gets a little more complicated, because first I need to find the derivative of this, and then the derivative of that. Or I can combine these two terms by finding a common denominator, although I feel that's more work. I'll label this term 1 and this term 2, starting with 1. X plus 2 over 2 times the square root of x minus 3. According to the quotient rule, I need to square the bottom part and then find the derivative of both of these. Once again, I'll label this u and I'll label this part v. Finding the derivative of u is easy, it's 1, and the derivative of v, we can go ahead and use what we did over here, where I found the derivative of x minus 3 to the power of half happened to be the following. And remember, we have a 2 out here, so we have 2 times 1 over 2 x minus 3 square rooted. This 2 and this 2 cancel out, leaving us with v prime as 1 over the square root of x minus 3. According to the quotient rule, it's actually almost the same as the product rule, except instead of this plus, there's a minus. And of course, you're dividing by v to the power of 2. So I'll rewrite the quotient rule right here in case you forgot. Now that we know what it is, my v was 2 times the square root of x minus 3 to the power of 2. That becomes 4x minus 3. Because if we distribute this 2 to the 2 and to this, we end up with 2 to the power of 2 is 4, and the square root of x minus 3 to the power of 2 is x minus 3. We know what u is. This part is x plus 2. We know what dv over dx is, and we found it to be 1 over the square root of x minus 3 minus v, which is 2 times the square root of x minus 3 times the derivative of u, which is 1. If we simplify this, we should get x plus 2 over the square root of x minus 3 minus 2 times the square root of x minus 3 over 4 times x minus 3. Now we're almost done. Remember, this was for term 1. We also have to find the derivative of term 2. We know the derivative of term 2. In fact, we found it earlier. The derivative for this is right here. So all I have to do essentially is copy this down right next to this term. Plus 1 over 2 times the square root of x minus 3. This expression represents y double prime, and that is how to find the second derivative of a function.